Good morning. My name is Jason Strayer. If you weren't able to attend my last talk, I'll reintroduce myself. I'm a senior program manager in the Entertainment Developer Experience team at Microsoft. It's my job to help game developers make great games for Microsoft platforms. I've helped developers from Xbox to Windows Phone 7, and then I'm incredibly excited to be talking about the new Metro-style apps and Metro-style games for Windows 8. This talk is about input. And you're going to hear me say it multiple times, what I really want to convey is that Windows is a really broad opportunity for your games, and that to get the most out of that broad opportunity, you're going to want to give your players great experience on a wide variety of devices. So I'm going to talk really briefly about those types of devices, but then I'm going to get into the different types of input that you'll need to handle in your game in order to give your players good experiences on each of those device types. I'll come back at the end and talk a little bit very generally about how I think you can put this together in your game. And the specific things that you'll see are code examples for using each of 4 major types of input that I'm going to cover. So, we're really familiar with PC games. We know about this hardcore gaming PC desktop that's got three-way SLI, it's liquid cooled, it's incredibly powerful. You can get really robust graphics out of it. And this is maybe what we've thought about when we've thought about a hardcore PC gamer in the past. But we've seen, most people are fairly familiar that over the last 5 years or so, there's been a real transition of gaming, not away from, but to also include laptops, where a lot of gamers can get quite a bit of power out of a basic laptop, and so they'll play a lot of their games just on a handheld laptop. There are some newer types of devices in the last few years that have started to appear, things like a convertible laptop in the bottom right-hand corner. A convertible laptop has a touch screen that rotates, so you can either have it in sort of a laptop configuration and use the keyboard and mouse, or turn it around and get a tablet experience. We've also seen what we call all-in-ones. An all-in-one is a combined single cabinet monitor and PC device. Generally, these come with a keyboard, but they're really oriented around a touch experience. You can think about these as the computer that you put in the kitchen so that you can look up recipes very quickly and scan through those on your PC. But they also make a really great desktop for productivity as well. And then, of course, here we are, last day of build. You all have gotten one of these as a giveaway. Hopefully you've gotten to go back and play with it in your hotel room and even start to do some coding. So it's really kind of the star of the show, if you want to say that. Tablet devices. And this is really a new kind of device for Windows in a way where we're thinking about a very touch-first experience. Mouse and keyboard are definitely possible, but really trying to design a UI and a whole experience around this specific tablet device. So if we think about this entire ecosystem and all of these types of devices that are going to be out there, we know about mouse and keyboard. Like, that is something as a Windows developer you probably have been programming against for years and years. And hopefully, if you're a game programmer, you've thought about game controllers as well. Gamepads are pretty straightforward. They've been on gaming consoles for decades. But maybe we haven't thought so much about some of these new types of input that are newer to the Windows ecosystem. Things like touch and even sensors, which you may have seen on other types of handheld devices, but are going to be an important part of gaming on Windows 8. All right, so for my first demo, I'm going to show you Marble Maze. Marble Maze is a game that you can download from the Developer Center. What's really great about this game is it handles lots of different types of input at the same time. So you can get this from the Developer Center. This is all source code is fully available. This is the reference application, if you will, for games built using DirectX and C++. So you can see here I'm using an Xbox 360 controller. Once I get it turned on, I can tilt the screen using the controller. And this is a basic Labyrinth app, so as I move the thumbstick, I tilt the board. I can also come back to the app and do tilts of the board using my finger on the actual screen. So I push on the bottom of the screen, it rolls to the bottom. I push on the top, it rolls to the top, right and left. I can even use the mouse and get the same experience. I click on the left, the right side of the screen, the top, bottom, and get exactly the same thing across all of these different input devices. And then I can even pick up this device out of the dock and, oh, let's see here. I have to re-enable that. Sorry. Ooh, demo faux pas number 1. So, let's see. Tell it. Let's see. Task manager. Sorry, I put in a special hotkey to disable this so it wouldn't tip while it's in the dock. So now I'm going to turn that off. There we go. And now, kind of a Labyrinth game the way it's meant to be played, obviously. I'm using this accelerometer that's in the tablet, and tilts of the device actually correspond, of course, to tilts of the board. And this is the prototypical Labyrinth game. When you think about how to use sensors, pretty much the first thing you think about is, oh, I'm going to make a Labyrinth game. So here we go. All right. I'll put that back in dock. Boop. Switch that. All right. Let's get this back on the rails. Oop. So, how should we approach this? From the get-go, from the start, as you start to build your games for Windows 8 Metro style, you should design your games around touch-first experiences. I imagine you heard this loud and clear in the keynotes. You've probably heard it across a lot of different sessions. Hopefully you managed to catch a number of the touch-oriented presentations. I'm not going to talk a lot about it, but really think about touch as the primary form of interaction that your players are going to use. But because Windows 8 is going to run not just on tablets that are really oriented around touch, but it's going to run on desktops, convertibles, all-in-ones, all of these different types of devices, you should support keyboard and mouse as well. We're definitely not encouraging you to go out and think about, oh, all I'm going to do is be making touch games because it's just for tablet. Think about all types of input. Add some flavor to your game using sensors. They won't always be there, but when they're there, things like a Labyrinth game really naturally lend themselves to sensors as the input control. And then finally, if it's a game, because it's easy to do so and it kind of makes sense, make sure you add game controller support as well for those gamers who've gone out and bought a device and want to use that with your game. So I'm going to start out talking about touch, mouse, and keyboard. The first object, if you managed to attend Chaz Boyd's talk or one of the other DirectX talks, they might have touched on this a little bit. Core Window is the new object for Metro-style apps that essentially is analogous to the old Win32 window. It's the object that you use primarily for mouse, keyboard, and pointer events. It's kind of the primary dispatcher. And I won't go through all of these, but obviously Core Window owns the dispatcher. You're going to use the dispatcher object to dispatch events in your render loop. So once per render loop, you'll want to process all events in a loop and then move on with the rest of your processing. It also has pointer position and pointer events that correspond to touches on the screen. And it has get async key state, which has been the primary Win32 API that you've used for keyboard input, particularly in a game, as well as key events. So we really, we approached Windows 8 and we thought about, okay, we really want to have great touch experiences, but we don't want to abandon all of the game players and all of the users that have mouse and keyboard. We want to make it really easy for developers to do both at the same time. So out of that came the genesis of this, the unified pointer API. So all of the pointer functionality that you see on core window, in each of those events, it actually not only maps to touch on the screen, but it maps to touch with the mouse. So for example, pointer press is either a touch press on the screen or a mouse button down. As pointers move across the screen, that's either considered a touch slide, that either originates from a touch slide or a mouse move. And then pointer release, hopefully obviously, it's a release of the button or a touch off the screen. And we have pointer wheel change, which corresponds to mouse wheel rotation. So this makes it really easy for you to get both sets of functionality without having to do a lot of extra work. Now, you might go a little bit beyond this, and one of the really exciting things about touch in Windows is that to be a certified Windows Touch solution for Windows 8, we require you to have 5-point touch. There will, of course, be some devices out in the ecosystem that your games will run on that won't have this, but we are recommending that you think about and design around the possibility for at least 5-point touch, because the majority of the devices that we see coming out will have that. Now, just as a side note, Windows kind of arbitrarily supports up to 256 points of touch. Hopefully, you won't ever be able to see that on a tablet device. But if you're designing a game that, say, runs on a touch screen in Las Vegas giant wall, or maybe on a Surface device, you might actually see somewhere in the neighborhood of this many touches. And when you start to think about that number of contact points on an actual device, it really gives you a lot of possibilities for your game. You can start to think about things like multi-hand virtual object manipulation. So, before maybe all I could do was some pinching or some swipes. Now I can actually interact with the screen in a much more natural way with 2 hands, turning gears, or maybe pulling and moving levers up, or making other movements that actually require more than 2 points of contact. Or we have virtual instruments. If you're a keyboardist, you wanted and desperately wanted 10 points of contact for a while, and you can actually go take a look at the piano app that's on your device. You can see you can get 8 points of contact there, I believe, maybe even 10, with all hands on the screen. You can also think a little bit more abstractly about effects and flourishes, and we can do things where I'm streaming my hands through water, and instead of just one little trail, now I've got all of these millions of these 10 trails, creating millions of scintillating sparks of light and fireworks across the screen. All of this becomes possible with multi-touch. And then you can think about multiplayer multi-touch, where with only 2 fingers it was probably limited to a single player, but now with 5 or more points of contact, you can actually have 2 players interacting with the screen, potentially sharing 2 ends of a device with fire buttons or something, and playing the same game. Touch input is very easy. I talked about core window. Core window is the object that you add event handlers to. If you haven't seen this in any of the presentations, I'll briefly touch on it. From C++, this is how you hook up event handlers. You use a typed event handler template that hooks to core window. In this example, I have a view object that I have all of my event handlers set up on. View, on, pointer pressed, released, moved. And then I set these event handlers using this notational syntax. This is a simple function that I'm going to use on the next slide. I'm basically converting touch radiuses to actual touch points in order to use for hit testing in UI. M_touches is my data structure for touch regions. M_pointQ is my point Q for UI hit testing. You can see here in my pointer pressed, I'm taking the point, converting it, putting it in my queue. This is a queue of the different places on the screen. In this case, somewhere else in my code, I'm going to look at that touch queue and say, oh, there's a touch in this region. That means tilt the board right, for example. If the pointer is released, the touch comes off the screen. I remove that from the touch map. And then finally, if the pointer moves, I update that pointer in my map as well. 2 slides, pretty easy. All that code, and I've got both mouse and touch support for free. So let's think about some simple mechanics that you would use touch for in your game. One I would call direct pointing. You can see this little blue dot. I'm actually highlighting the spaceship here. This actually maybe generalizes more to a role-playing game or an action game. And this is where you use touch to tell where you want the player to go. So maybe I touch on a unit in a strategy game, and then I touch a point in the map, and that tells that unit to go to that spot. Or in this game, if I touch on any place, that's the direction that it uses to move the character. Something that's a little bit more natural and actually gives your player a little bit more immersiveness is actually using more complex gestures like drags, swipes, moves. So here, I actually use a swipe movement from the character towards the spaceship, and that causes it to move in that direction. And this is one of the games that's pre-installed on your tablet. I encourage you to go take a look at it. It's Lost in Space, I believe. And it uses this mechanic for control. We saw Marble Maze. Marble Maze uses, for touch, what I'd call direction control. Direction control is generally you find regions of the screen that correspond to the movement. So I would touch the top of the screen if I wanted to convey movement of the screen or movement of the character. And this is really natural, like for, say, an action, third-person perspective action game where you have a character in the game world. You can kind of just easily move your finger around the screen, and it causes them to move around in the environment. And that shows, up, down, left, right. Virtual thumbstick controllers are becoming very common on mobile devices today. This is a really good mechanic to use. If your game is a first-person perspective shooter, you'll see this game a little bit later in my presentation. This is a simple 3D game. It uses virtual thumbstick controllers. You can see we've mapped out a couple regions of the screen, and this is where you put your thumbs. So if you're holding a tablet device, where you move your thumbs inside that region corresponds to the actual movement of, say, like an actual gamepad where you have 2 thumbsticks on it. And then, last type of mechanic I'll talk about, and there's 100,000 more, is virtual manipulation, where the character's actually moving things inside the game world. This gives you a very rich touch experience, and this is definitely something you should think about as you start building Metro-style games for Win 8. Some quick tips. Be conscious of swipes at the edge of the screen. As you're now familiar, most of the system UI, system interaction is brought up by these swipes that happen coming from off the screen on the screen. If you're having the player do lots of frantic movement at the edges of the screen, you might start bringing up UI. This is kind of the moral equivalent of the player accidentally hitting the Windows key in a first-person shooter. So be careful about that. Context visualization is something that's controlled by the user. They get to decide whether it's on or off. So just think about that from your game's perspective. If it's there, generally you don't want to add extra context visualization in your game unless you feel like it's particularly needed. Feedback to the user that you've actually touched the screen is good, in the form of sound or actual behavior changing in the game. And then finally, since game players are going to be using lots of different apps and lots of different games across lots of different devices, make sure that for the consistent UI behaviors, for the consistent touch behaviors, things like press or swipes or drags, think about using the built-in gesture recognizer. I don't have code for that in this presentation. There's lots of other presentations you can check out. It's covered in the docs. But think about that because it's better for the system to implement the actual timing, how long a press is considered a press and how the swipes work, rather than having every single game reinvent that and then having users confused about timing or how those actual gestures work. What about keyboard? I talked about get async key state. If you've built games before for Win32, you've become familiar with this API. Get async key state is generally recommended above using actual keyboard events because Keyboards have a repeat rate and a key delay setting, and the events are actually susceptible to that. So when I push a key down and I leave it there for about 500 milliseconds, 5 seconds, depending on what the delay rate is, it'll actually start repeating and I'll start getting multiple events fired. So I recommend actually using get async key state and polling that once per frame to actually get the state of the hardware. Now, note that for Metro-style apps, if you've done this before in a game, you actually can't disable the Windows key or shortcut keys, things like sticky keys. I think this is a concern for games, and I'd love to hear feedback from you if the game that you're building is affected by either of these. Mouse, again, unified pointer API, that makes it really easy. It's not a lot of extra work for you on mouse. But if there's certain circumstances where you want to use a polling approach, you can poll the button state using get async key state. This corresponds to physical mouse buttons, not virtual buttons, but it works essentially like get async key state does for the keyboard. Now, one really important gotcha in the developer preview, once you start going out and building your apps and your games, to think about. The mouse movement that you get out of the pointer point API off of core window is absolute. It's confined to the Windows surface. So as you drag your mouse around on the Windows surface, you'll get values, but once you get to the window, those values will become clamped. For things like a third person or a real-time strategy game, or things where you're actually clicking on parts of the environment, that's probably not so much of a concern. If you're making a first-person shooter, for example, you're not going to be able to fully rotate without moving that pointer to the edge of the screen. There's a couple things that we've generally done in Windows to solve this problem. The first one is use of raw input through WM input. And the second one is kind of a hack of using set cursor pause to continually force that pointer back to the middle of the screen. These things are available to you for your desktop games, but for Metro-style games, they're not available in the developer preview. And again, if you think that you're affected by these things in your games, I'd love to talk to you. Please come up and talk to me after the talk. For now, most types of games and most types of applications will be able to work around this. Here's some code. This is incredibly simple. This is how you use get async key state. The only gotcha to talk about here is the value that you get out of this is actually a bit field. So you want to use the ampersand operator here to check that bit field to see whether the key state is down. If you used equal here, it would actually be reminiscent of having keyboard repeat rate on in how it actually worked. Okay. Moving into sensors. I'm going to show you my next demo here. All right. Okay. Is that coming up yet? Okay. So this is a really simple application that I wrote. It's sort of a virtual tablet in 3D space. You can see I'm rendering some video onto the tablet screen. And I built this really to test all of the different sensors in the environment. And you can see as I rotate the tablet device, the movement of the device in 3D space corresponds to how I move the device. And I can get full rotation in all 360 degrees. This is actually using direction, so you'll notice that the tablet is facing that direction, and that's actually mapping to magnetic north, not to the position that I'm holding it. All right. So Windows 8 supports a wide variety of sensors. The 5 that I'm going to talk about that are most interesting from a gaming perspective are accelerometers, which measure the force of acceleration along the X, Y, and Z axes. This basically means if your device is flat, you get a 1g acceleration along the Y-axis to correspond to gravity, of course. Gyroscope, which is changes in velocity around each of the axes. This means if the device is flat, you're getting no reading at all, but as you rotate the device in any direction, you get gyroscope, gyrometer readings. Inclinometer is rotation around various axes. Inclinometer, would, you get an actual rotation around X, Y, Z. Compass is an actual heading direction, just like compasses, comes from magnetometer data. Generally, sensors in Windows 8 will correspond to magnetic north, not real north, true north, but the actual API does support both of those. Whether the driver does or not, you'll have to query that. And then finally, we have this concept of an orientation sensor, which I think is the most interesting part of all of the sensor APIs that we have, and really the one I'm going to recommend that you look at for your games. Before I get on that, I just want to mention one thing to kind of explain how these different sensors work. The accelerometer, gyro, and magnetometer are actual sensors, hardware sensors in the device. When you query the API, you're essentially getting the raw data that comes from the sensor itself. Accelerometer, gyro, that's actually what you get. But all of this data is fed through sensor fusion, and what's really exciting is the sensor fusion is often performed in hardware so that you have really low CPU load for all of the math that goes into combining all of these different types of sensors and giving you actual virtual sensors as a result. So I get a compass, which is, as I said, a magnetic or true north heading. I get an inclinometer, which is heading controlled rotation around each of the different axes. And then finally, I get the orientation sensor, which is really a really powerful combination of all the sensor data to give me basically a position in 3D space of that device that I've rotated. So I'm going to get a little mathy here. The device orientation from the orientation sensor comes to you in the form of a quaternion. A quaternion is similar to a typical axis angle rotation that you do in a game, but slightly different. What it gives you is basically a unit vector in space with an angle of rotation around that. This corresponds through all of this math down to a W, X, Y, and Z values. You can kind of look at the math here, but W is essentially a cosine of that angle, and then X, Y, and Z roughly correspond to that vector. They're not a unit vector. Altogether, W, X, Y, and Z are actually a 4D unit vector. Now, what's exciting about a quaternion is it is just about the most compact form of rotation that you can get to express device changes. If you're a 3D programmer, you're really familiar with rotation matrices, 3D rotation matrices. So you have a number of 16 elements, 9 elements that you use to do rotation in your 3D world. This is 4 floats to express the same thing that you would with the rotation matrix. So it's really great for passing this rotation data back and forth from the hardware at a really faster rate. How do I recommend that you use this in your game? Hopefully, a lot of this is kind of jumping out at you, but to give you some quick ideas, you can think about using the quaternion to control your camera. So if you're in a first-person shooter and as you move your camera around, as you move the device around in 3D space, you're actually moving the camera. Or you can use it to actually rotate objects. So as you saw with Tablet Sim, as I actually move the device around, I use that quaternion to actually create a rotation matrix that rotated the state of that object. A few gotchas to watch out for. When you're making a game, you're generally working in a system where negative Z extends out in front of you, positive Y goes up and X goes to the right. And you may be left-handed or right-handed coordinate system. The device orientation is expressed according to the W3C spec, which is a right-handed coordinate system with the Z vector going up and positive Y going forwards. So when you're using this, be really careful about the either handedness changes or the changes from the device orientation into your actual game world. Also be careful if you're working with some legacy code where you use actual Euler angles for rotation. A typical problem with Euler angles is gimbal lock, where you get to certain points where you can no longer express additional rotation. Quaternion's really great from that, and that's what you get out of that fourth component of the vector. So be careful if you're using this in a legacy system where you're passing the data back to something that can't express full rotation. And then as I say here, from the orientation vector, when you get it out of the device, it actually corresponds to device is flat. I have it in landscape orientation towards me, and then the device is facing magnetic north. That will give you a 0001 quaternion, which is essentially your reference position. Let's take a look at the code. Quick gotcha to watch out for. When you're working with sensors, particularly things that rotate the screen, you want to turn off auto rotation. Nothing will be more of a disruption for your user if suddenly the game is auto-rotating its position in space as they move their screen around. This code will actually allow you to force it into landscape orientation. This is how you get the basic orientation sensor device. All of this code is similar for each of the other sensor types. I'm only looking at orientation sensor here today, but you can do different things in your code. This is how you hook up an event object. We saw that earlier. In this case, I'm hooking up the reading changed event off of the orientation sensor. The reading change corresponds to essentially whenever an actual reading is sent back from the hardware. In my case, in my code, I'm actually not even using this. I'm hooking up the event handler because in the developer preview, you can't change the report interval unless you have an event handler hooked up. So I'm just setting that in order to be able to change the report interval. The report interval controls how often that the hardware is communicating changes in state back to the actual API. Since I want to have really low latency for a really sensitive game, I'm setting this to the minimum report interval. You can do experimentation in your game and find an interval that works for you. All right. So somewhere else in my code, once per frame, I'm calling get current reading off of the orientation sensor. I'm polling the API and then getting out a sensor quaternion object. Now what's really cool is now that I've got this quaternion, we have a math library called DirectX Math that ships in the SDK. It ships in the SDK you have on your devices. And you can use this math library to convert these quaternions into an actual rotation matrix that you can then feed into your graphics pipeline for manipulating objects. I'm making a small change here to convert from orientation space to world space by negating the x and w vectors, components of the vector. And then I'm using XM matrix rotation quaternion to create that matrix. And then, this is an exercise left to the reader. Pass that matrix through my 3D rendering pipeline and use that to do an actual rotation of the object in 3D space. All right. Next, we're going to talk about game controllers. And I'm actually going to demonstrate two things here. All right. I'm going to bring up Simple 3D Game. This is another game that is available on the Developer Center. I'm going to turn on my controller. Oh, I think I want to keep that over there. You could think of this as a really bare bones first-person shooter type of game. This is a great code example to look at how to start coding. Obviously, you'll want to go in for your games and add a lot more content and a lot more complexity to your levels. Let's see if we can get my device connected here. Uh-oh. All right. Let's see. Where did my controller go? There we go. So I'm going to plug my controller here into a tablet. There we go. There we go. Using the game controller, I get a very typical first-person kind of experience. I can use the thumbsticks to move around in the environment as I move through 3D space. And then I can fire using the triggers of the game controller to hit actual targets. I have all these balls moving around in the environment. And of course, this is all first-person perspective. Now, since I didn't demonstrate it on the last set of slides, I do want to show you using this game from an actual sensor. I need to use my very simple end task here. All right, go back. Pull this device out of the docking station. All right. Oh, okay. And then we'll go here. And then this is going to be an example of using the sensor to do something like augmented reality, perhaps, where as I move the orientation of the device around in 3D space, I'm actually reorienting the camera inside the game world. This makes a really rich gameplay experience because it's almost like I'm interacting with the real world in a way. So I can move the axis up, look at the ceiling, I can look at the ground, I can have targets everywhere, and all of this is coming out of the same game that's using both game controller as well as sensor axis. So, game controller input. The API that you use to add game controllers to your application or to your game is Xinput. Xinput has been on Windows as an API in the DirectX SDK for a number of years. It's now officially part of Windows 8. You use the Windows SDK, the header, Xinput header, and the library for this ships in the Windows SDK, and it's available to all C++ Metro-style apps. If you want to use the game controller in a non-C++ app, there were a number of talks about how to have mixed languages. It's actually fairly easy, and I think if you got to see it, they actually demonstrated wrapping the Xinput API in one of the keynote sessions and using that from within an HTML, JavaScript, or a XAML app. Xinput's beauty, its elegance, is that it's very simple. It allows you to access a wide variety of devices from only a very few number of APIs. Essentially, in the most naive use of game controllers, you only have to call one API. That's Xinput get state. A little bit better usage I'll show you in a second. There's a few more functions, but there's no more than 6-7 functions that you actually need to use in your app. The API supports headphones and microphones, as well as has basic controller vibration. Nothing as sophisticated as full force feedback support, but enough to give a certain rumble to the controller. And then something that's maybe a little bit unique about using game controllers. Xinput, since it's a cross-platform API across Xbox 360 and Windows, it comes from a heritage of having multiple players on the same machine. So if you're designing a game that allows for multiple players to play concurrently, game controllers are a really great way to add that support for a Windows 8 Metro-style game. Now, hopefully most people have heard of the Xbox by now. If you haven't, it's a gaming system that Microsoft makes. I believe, I'm very biased of course, that the prototypical, the ultimate apex of game controllers is the Xbox 360 game controller, and that mankind will never make a better game controller. I am a little biased. We do obviously support that game controller, both in wired and wireless forms. So you can see here I've got a little wire coming out that I plugged into my tablet device through USB. We also have wireless devices. This is a wireless device. It connects to a little puck, which you may be able to see. This is your wireless receiver that you use for your wireless devices. Mine decided to time out while I was up here, so I had to switch to my wired controller. And we also have headset peripherals. Here's a wired headset peripheral that connects to the bottom of the controller. We also have a wireless peripheral that connects to that same wireless receiver. This is all great, but we have a lot of support for a lot more devices and not just Microsoft products. The Xinput standard is a common standard that's implemented by a number of different hardware vendors out there. Here are a number of examples from one particular vendor, Mad Catz. who was gracious enough to allow me to use their images in my presentation. We can see a controller device here, if you want to think of it as a reimagining of the Xbox 360 controller. We have a simple drum kit here, guitar, steering wheel, a traditional flight stick, and an arcade pad. All of these devices are supported by this very simple API. We have in XInput a notion of types and subtypes, and there's different subtypes. And what it gives you is you can expect that the same control mechanics will apply across all of these devices. So as a game developer, you don't have to go and figure out, oh my goodness, is this a controller with 10 buttons or a controller with 5 buttons? You know that it's always going to support A, X, Y, and B. And you know that generally you're going to get that functionality of each of these devices. But then if you want the extra functionality of, say, a drum kit, there's additional members of the state structure that you can use to get more functionality of that. Here's some simple code. Because polling for game controllers when one's not connected, there can actually be a delay, which introduces some latency inside your frame loop. You actually want to use a timing loop and check for a controller to be inserted less frequently. You think about this as checking every 5 seconds or maybe every second. Test this out in your game. And then you use XInput get capabilities. This will return an error if there's no controller connected, or success if not, if there is one connected. Note that here I'm passing in 0 for the first parameter. That corresponds to the user index. We support up to 4 controllers attached. So if you're in your game, you're actually supporting multiple controllers, you'll want to check for other values there in a for loop. Of course, if this returns success, I pass on to the next part of this where I call XInput get state. This is that really simple polling function that gives you the XInput structure, the XInput state structure. If this fails to succeed, I consider the device having been detached, and then I go back into this querying for that device every 5 seconds. Processing input is incredibly simple. It boils down to a matter of inspecting fields into that structure. The XInput state is the structure. I'm checking the gamepad union of that and looking at the W buttons. I ampersand that with XInput gamepad A to see if the A button is pressed. And then if the button was pressed and I release it, I trigger a sound effect. Here's an example of using the triggers, or actually the thumbsticks. So the thumbsticks give us a continuous value, and I check this with a dead zone. A dead zone is something that's very commonly done with game controllers because there's a certain mechanical variance between devices where the the static position or the default position of the thumbsticks varies sometimes from device to devices in the very sensitive ranges. So you actually want to do some testing in your game and make sure that in order to have consistency, you consider a certain zone, a certain range inside as not being input. So here we use a dead zone and then set it to say it's not input if it's inside that dead zone. And then finally, like we do inside Marble Maze, I'm tilting the board here based on the position of that thumbstick. Okay, some tips and tricks for using XInput in your game. Recommend that you use the terminology guide. The terminology, there's a link in the presentation when you get a hard copy, or you can go search on MSDN for it. This helps you use some consistent naming in your game so that all games kind of talk about the controller in the same way. Make sure you turn off vibration in your paused or suspended state. Now that we have process lifetime management and your app may be sort of in this Schrodinger's cat kind of state where maybe it's terminated, maybe it's not. Last thing you want is for your controller to start vibrating unexpectedly. So in your suspended handler, make sure you use XInput enable to turn off the controller. And then inside your UI, your game UI, make sure that you use the controller to navigate that. You don't want the player to only have control inside the game. When you do that, very important to use consistent button conventions. It's really going to trip your users up if start becomes something other than accept or move forward, or A is not the standard accept button. And we have graphics for all of these buttons, so you can add them to your game UI. Okay, so let's put this all together. This is a big, ugly chart that I put together that hopefully looks kind of scary, like, oh my goodness, we've got all of these different types of devices, and touches on some, and on others it's not, and sensors are there on some, and others it's not, and game controllers are there on optional. I think the way to digest this is to kind of come back to what I talked about at the beginning, that use touch as your primary form of input, support mouse and keyboard, don't disable that, it's very easy because of the API. Consider sensors for optional functionality in your game, or enable them when they're there. And then for a game, since game controller, since it's probably the one type of input that players can actually use on any type of device, consider adding that as for folks who have those controllers. Another general concept to kind of talk about real briefly. Across all of these different APIs, there's sort of two different ways of getting at the data. For whenever you're working with events, you generally have an event handling approach. And when that's happening, what basically happens is the driver's sending data into some event queue underneath the covers of the API or inside the driver. And that stuff gets queued up until your app gets to that in its render loop and actually calls dispatch on core window to dispatch those event handlers. And that generally happens inside your render loop. What this can cause to happen is introduction of a little additional latency, where the event has actually happened, so the button was pressed, but you don't actually get it in your game until a frame later. And that can be 16 milliseconds of latency or less. And if you're a really twitchy game, first-person shooter, that can actually be noticeable by your players. If you're a twitchy game, you often are looking for things like a polling approach, which I'm showing on the right-hand side. In this type of approach, the device is constantly sending the data to the driver, and it gets dropped on the floor if there's nobody there asking for it. And then when your frame actually goes to pick that up in its render loop, it's actually getting the most recent set of data with the least amount of latency applied to it. The disadvantage, of course, is game events might actually get dropped on the floor. So if you push the button really fast and let it up before the game gets to its next render loop, you've now lost a button press or a keyboard press. So it's really good to think about which of these two types you want to use for the different types of control mechanisms. If it's something where you actually need to guarantee that you get the data, then consider using event handling. If it's something where you want really low latency effects, then use polling. And some APIs, of course, are polling only, like xInput. You have to use a polling approach for that. And then some APIs, like the touch APIs, are generally event handled only. So you'll be mixing this in your game. And this kind of leads into another concept of continuous versus discrete data. You might also hear this called analog or digital data. I call it continuous. Continuous is data that's just kind of constantly streaming to you, and as a game, you don't really care so much if you miss part of that data. So, for example, if I'm moving this device in space and I'm getting different readings, I don't care so much about the readings in the middle. I kind of care where's the device at the time that I get the state and feed that into my simulation of physics or other mechanics in my game. This includes mouse movement, sliding of touch data, as well as triggers on the game stick or thumbsticks. Discrete data, like I kind of teed up in the last slide, this is data you absolutely don't want to lose. The last thing you want is for the user to lose that keyboard press. And this is typically discrete. It's binary. It's down or up. You don't care so much about what the intermediate values are. You want to know, hey, did the button go down or not? And I think this is interesting to talk about from a how do I put this all together perspective, because you want to match control mechanics across similar types. So in your game, you're going to want to match touch slides to mouse movement or to sensors. But in your game where you're using key presses or gamepad buttons, you'll want to map those across those other types. And when you use this, it actually makes it very easy to support lots of different controls at the same time. 3 simple approaches here. I think you'll come up with a lot more. Sort of the easiest approach is you check to see if touch is supported. If it's supported, then that's the primary form of input in your game. Or then, if not, you check to see if there's a keyboard. Or if, and you kind of walk it as in a priority scheme down through different types of input and check to see if they're there. Maybe a little bit friendlier approach, particularly if you want your player to be switching between types of input. Consider action mapping, where a screen tap, pressing the spacebar button down, pressing the left mouse, buttons on a controller, etc. All of these things map to some action, like fire a weapon. And you map the input to the action, and then later on you use the action in an abstract way to control game behavior. And then sort of a last approach is thinking about customized experiences where different inputs do different things. You want to be careful about this because you don't want these to be required, but think about in a first-person shooter where if I tilt the device, it kind of corresponds to a head tilt in the game. You don't need that, but it gives you a little bit extra oomph, a little extra flavor in that game. You can kind of look around corners and stuff. And so think about optional game behavior as a supplement, not as a requirement. So I walked through this list earlier. I want to kind of come back to this list again and talk about how does this map. So direct pointing, where I'm tapping on the screen, for touch, maps really well to actual mouse pointer presses. It doesn't map as well to, say, the game controller, which, unless you have, say, a cursor and you're moving the cursor on the screen with the game controller, you can't do that. It doesn't map as well. And obviously for sensors, there's really not any mechanism here. So as a control mechanic, this is a little bit limiting in terms of how you use it. Swipes, moves, and drags are maybe a little bit better. You can think about a swipe, again, maps really well to mouse. It maybe maps really well to movement of the thumbstick on the game controller. It might move really well to some keyboard presses, things like that. So this is maybe a little bit better form of input interaction. Plus, it's got a better feel as a touch control. Direction control, touching various regions of the screen. This maps really well across all different types of input. So obviously, keyboard buttons, obviously touches around the edges of the screen, direct D-pad on a game controller, a really great control mechanism for supporting lots of different types of input. I didn't demo this, but in Simple 3D Game, we have the virtual touch thumbstick controllers. These are actually inspired by the thumbsticks you have on game controllers. So naturally, it's a great, it maps really well to that. Maybe not so much to mouse and keyboard, although you have the traditional mouse and keyboard WASD look and keyboard presses that it does map to. Virtual manipulation. Now, this is something that I think is a really valuable and interesting way to add touch to your game. The tricky part about it is it's going to take some real creativity to think about how that maps to other types of input. But you could think about turning a wheel with gestures. You could think about also adding the ability to use mouse gestures around the edge of the screen. So maybe you move the mouse in a circle, and that corresponds to the rotation of the gear. Or mouses on different levers or different points of interaction. So think about that. And this is probably an area where you'll need to do some play testing, kind of think about, I want to offer this really cool functionality in a tablet, but I still want it to be playable on a desktop PC. And then another last thing you can kind of think about is multimodal. So what happens if the player has mouse and touch? Can you do some cool things where you're using the mouse maybe for looking, but then you're using touch to actually identify enemies on the screen? So maybe you're first person, use the mouse for look around, and then you actually shoot by touching something you want to shoot at. And hopefully you can come up, your game developers, hopefully you can come up with lots of other really creative ways to mix different types of input at the same time. A little gotcha here that kind of applies to a couple types of input. You might be playing your game with a game controller or with sensors, and then suddenly, poof, the screen just got dimmer. or a little bit longer, actually the machine's gone to sleep. The reason this happens is that X input and sensor data is not treated as actual sort of live input. Fortunately, we have a solution. There's on the Windows system.display, there's a request active method that you can call. The naive approach is to just call this once per frame. A little bit better is to call that at once per frame, but also call request release when the game is paused or suspended. And then finally, really probably the best thing to do is have some sense for when input is timed out, like you haven't seen a change in input for a while, and then actually call request release at that point. Well, I'm winding down here near the end of the talk. Thank you very much for paying rapt attention up till now. This really started out as a talk that was many hours long, and unfortunately, in order to get it into 1 hour, I had to trim a lot of content. I encourage you as game developers to not limit yourself to these 4 types of input, but actually think about all of these other rich, very interesting types of novel input that come off of new tablet devices. Microphones, cameras, pens. We even have light and proximity sensors, location. We had lots of great talks where we talked about all of these things. I encourage you to go up to Channel 9 and take a look at some of the other talks, particularly on location or maybe on audio capture. The message I want to give you, I'm going to say this again here in a second, is we make it real easy to get this input so that you can focus on the design of your game and how this all fits together. All right. Well, to wrap things up, really want you to walk out of here with one real key takeaway, that Windows is about a wide range of hardware. Windows is about great desktop PC gameplay experiences as well as great tablet experiences. And really, you shouldn't develop or design your game for just one footprint. Don't make a tablet game that only runs on a tablet. To give your gameplay, your users, the widest reach of users, the best experience, give them great input controls on all types of hardware. Design for touch first, support mouse and keyboard. And then finally, use sensors and game controller devices to create unique experiences for your players. And a talk on input is kind of like pulling a thread out of the sweater. That if you keep pulling and pulling, there's so much more information there. This is just scratching the surface of the other talks here at the conference that you should go take a look at after this if you missed them, with lots of great information. I hinted that there was a way to use X input from a JavaScript or a XAML-based application. There was actually a lab, and I think there have been a lot of other talks that kind of talk about mixing languages, and that's pretty easy to do. Finally, further reading and documentation. There's plenty of documentation out there on X input. All of the different types of input that I've talked about, very easy to use, covered in the Developer Center. And then I encourage you to ask questions on the forums. If you go up to the DirectX Developer Center forum, I'll be watching those and look forward to your questions. So thank you very much for paying attention. I have a special surprise for those of you that stuck it out the entire time with me. I'm going to ask some questions here to test you out a little bit. So what's the API that you use for game controller input? Let's see. I heard, thank you. There you go. You get get a free bag. So I've got some swag to give out here. Let's see. What are someone raise your hand. What are the 5 different types of sensors that Windows 8 supports? Okay, over here. The orientation sensor? Awesome. I'm not going to throw anything at you, so come up here and I'll give you your swag. Okay. If you're designing a game, what should you first, for a Windows 8 Metro style app, what's the first thing that you should look, first type of input that you should design around? Saw your hand go up first. Exactly, thank you. Okay, let's see, what's a good question to ask? Let's see. What is the name of the object or the class that you use to get keyboard and mouse events as well as touch events? What was that? Close. Core window. Great. Thank you very much. For those of you that asked questions, come up here. I have some prizes for you. For the rest of you, I set some Connect pens on the back table. Feel free to take one of those so I don't have to take it back in my luggage with me. I think we're getting close to the end of time, so we won't take questions from the mics, but if you have questions for me, please come up. And thank you again very much for not only... Thank you very much not only for coming to my talk, but also for coming to Build. I know this is a lot of time out of your schedule, and have a great development on Win 8.